Good afternoon, everyone.
Good afternoon, sir.
How are you all?
Fine, sir.
Very good. Okay, listen, everyone. Today we'll study one beautiful topic, normal reaction. What it is? Normal reaction. Actually, this is a force, normal force. When two objects are in contact, okay, so there one force acts on two objects. That is called basically normal reaction. We'll understand what is this one. So basically it is a contact force and it acts when two objects are in contact. Yes or no? Either one object is rest on the floor, there also normal reaction acts, or two objects are in contact, side by contact is there, normal reaction acts. And based on this normal reaction, many questions will be asked in your exam. Okay, your board exam also and competitive exams also. Okay, so what will understand first? What is this normal reaction? Little some properties. What is that exactly? And we'll understand how it acts. If it acts, it is a force. It is a force, I told, right? Then what is its direction? What is its direction? This and all we'll try to understand about normal reaction, and we'll try to calculate what is its value for different situations, different problems. Okay. So write everyone heading normal reaction. Now come to the topic here. Normal reaction. So right, first point, remember, normal reaction is a contact force and electromagnetic in nature. If you see the origin of this force, it comes due to electromagnetic interaction of atoms, okay, of two objects. So surface, when contact is there, contact surface is there, then this normal reaction basically is nothing but interaction of electromagnetic interaction between atoms. So normal reaction is a contact force and electromagnetic in nature. Now next, write normal reaction acts always perpendicular to the contact surface. So direction of normal reaction, okay, in illustration we'll try to understand. Alright, normal reaction acts always perpendicular to the contact surface. Okay. Always perpendicular to the contact surface. You should identify the contact surface, it will be perpendicular to the contact surface. So normal reaction. And remember, normal reaction is action reaction pair. Is action reaction pair. So this force exists in pair, you know already. So normal reaction also exists in pairs. So it is action reaction pair. Write down these points. To write down first. Normal reaction is a contact force and it is electromagnetic in nature. Normal reaction is action reaction pair. Now illustration will give to understand what is normal reaction. Illustration. Okay. What is the illustration here? Now all of you listen carefully. An illustration I am giving just to understand what is normal reaction. Now suppose this is your floor. Okay. This is the surface of earth you consider, Norwich. Okay, small surface consider. It is straight line like that I am taking, floor. So I am considering it is what? Floor. And this is your object. Object mass how much? M. Object mass how much? M. Now this M is resting on the floor. Okay. Now tell me, where is the contact surface? This line is contact surface, or this line is contact surface, or down line is contact surface? This middle one here, right? This one. This one is basically what? Contact surface. So this one I'll make it one circle and I'll give in a different color. Let me write. So here basically what you are coming, now here you are getting contact surface. This is your contact surface. Two objects, this floor and this mass. This mass also, what will write basically? Now in other words, sometimes I will tell mass or will tell what it is? Block. I will tell block. Yes or no? Mass, floor and block, both are there. This block is resting on the floor. Okay. Now let's understand how normal reaction acts in that contact surface. Now if you little here, I'll try to see carefully what I'll observe here. I'll see like this. This is your mass. Let me separate mass. Let me separate floor. Let me separate floor. Now here I'll see here normal reaction is acting like this. Normal reaction on this mass M, it is acting upward direction. Normal reaction on the mass M, it is acting on in upward direction, on mass M acting in upward direction, and for this floor it is acting downward direction. That one I'll give as N, normal reaction. I told to the contact surface always it is perpendicular. So here perpendicularly this force acting. See, this force is acting on two different bodies. What were the different bodies you have taken? Now one is block. One is block and another is floor. So this force acting on two different bodies in opposite direction and equal magnitude. So that's why it is a action reaction pair. That is what written here. Action reaction pair. Yes or no? Now what we'll do? Now we want to calculate this normal reaction for this particular picture. When this object at rest, I told you this object at rest, then you say what is the normal reaction for this object? Normal reaction for this object. See, when you want to find something like acceleration or what is the normal reaction or tension, like that type of things you are finding when for any object it will be asked. First you need to do something what that is called free body diagram. What you need to do? Free body diagram. What is that free body diagram? Now along this mass you observe. Along this mass you observe, take it separately and you see how many forces are acting on that. What you do? Mass you take separately and see how many forces are acting on that, in which direction motion is there or which direction motion is not there. Accordingly you apply Newton's law, Newton's second law. Okay. So what I'll do here, now I'll take this mass separately. I'll take this mass separately M. Now you tell on this mass M due to floor, which force is acting? Normal reaction. In which direction acting? Upward direction. So that means on this mass I'll give one upward force, that is N. What it is? N. Normal reaction. And you already know about gravitational force. What do you know about gravitational force? Now on every object, gravitational force will act in the downward direction or towards center of earth. So now on this object also gravitational force will act, which is nothing but mass of this object into acceleration due to gravity. Yes or no? Mass of this object into acceleration due to gravity. Everyone try to understand carefully. So on this one object, one force is normal reaction and another force is what? Acceleration to gravity in vertical directions. It is acting like this. N is vertically upward and mg is vertically downward. This one also you can call weight of the object, W. Okay. Now next what is happening? Now here object is not moving. Two forces are acting on the object, but object is not moving. That means what? These forces are balancing each other. When object no motion is there, that means it is at rest or it is at equilibrium. That means what is happening here? These two forces N and mg, they are balancing each other. So weight and normal reaction are balancing each other. So I can write directly N equal to how much? M times g. Did you understand or not? So when object at rest, how to find normal reaction? Now simply you equate with what? its weight, equate with its weight, N equal to mg. Yes or no? Clear idea? No doubt. That means this floor is giving a force normal reaction to this mass with N. That means this object should move upward if it is giving only N force. It should go upward, but it is not going upward, it is at rest. That means some other force is balancing that. Who is balancing? Mg. Okay. Yes or no? So N and mg balancing, that's why I wrote N equal to mg as object at equilibrium. Clear idea? Now suppose this mass is 100 kg. What will be normal reaction here? 1000 Newton. If G value is 10. Okay. So 100 G will be normal reaction value. Clear idea? So already you know a little idea about this weight, right? If you don't know, I will explain here little. You know about gravitational force. Every object on earth surface will be attracted towards the center of earth with a force that is called gravitational force, or that is also called weight. Okay. So weight is nothing but it is a force with which earth attracts every object towards its center. And if earth radius r, mass is m, then that weight is nothing but it is g, or gravitational force equal to g mm by r square. Capital R square you take here. Capital R square. All of you take capital R square. Okay, radius is r taken. Now here what will happen? Now here this will give you mg. This will give you mg. Okay, because gm by r square is nothing but it is an acceleration due to gravity. Acceleration due to gravity. So it is becoming mg. So weight is nothing but mg. Yes or no? So remember, gravitational force is a force, or weight is basically a force, and its SI unit is Newton. SI unit is Newton. Clear idea? So this much idea you must keep about gravitational force. And gravitational force, for every object it will act toward the center. Suppose I am telling one object is present here, mass m. Where is the gravitational force? It will be towards, this is the center of earth. This is the center of earth, so it will be towards the center. Here one object is there, suppose. Here one object is there on the surface of earth. Here one object is there. Then it's also towards the center. Gravitational force will act. Because gravitational force is attractive in nature. So between two objects always it will be attractive. So this, on this M, it will act towards the center. Clear idea or not? And weight value always remember, mass of the object into acceleration due to gravity. Clear? So this is what we introduce here. Weight equal to mg. Weight equal to mg. Clear idea? No doubt? Okay. Normal reaction, did you understand? Did you complete writing? Okay. Now I will go for next thing. Another case we will take. One case we will try to understand how to find normal reaction. No doubt about normal reaction? Okay. Now come here. Now I will take one case, case 1. One special case I will take case 1. Here I have a lift. What I have? Lift. On this lift I have a mass. I have a mass or a portion, anything I have, mass m. Okay. Now this lift is moving upward direction with acceleration a. Upward direction, the acceleration how much? A. Yes or no? Here this m is, can be one person, can be any object, anything. And here I will take something, I will take like, here suppose it is present on a weight machine. I can tell like this. This mass is present on the floor, but here one weight machine is there. Let me take one weight machine here. This mass is present on a weight machine. Okay. Now this is your mass m. This is your mass m. Clear idea? Here this is a weight machine you are telling. This is what total the system. This is basically a lift. This is a lift. And this lift is moving upward with acceleration a. And this one you are telling one weight machine is there. In the below one weight machine is there. Okay. Now listen. Here question will be, what will be the measurement taken by this weight machine, or what will be the normal reaction acting this m, or what is the apparent weight of this man when lift is moving upward direction. Lift is moving which direction? Upward direction. That means this case is what? Now lift is moving upward with acceleration a, with acceleration how much? A. So in this case we are understanding. Okay, yes or no? Are you getting the point? Now how to approach this? I told you to solve any problem based on Newton's law or related to Newton's law or mechanics problems. Always what you need to do? You need to do free body diagram. What do you mean by free body diagram? Now this object you have to separate from the system, you have to take individually. So I'll write here, this whatever we have done here exactly whatever you have done here, this one is called basically what? This one what you call? Free body diagram, FBD. What do you call? FBD, free body diagram you have done. So same thing we'll do here. What we'll do? Now we'll write here free body diagram of this object, FBD. FBD means so what I'll do now, I'll take this mass separately, M I'll take separately, and I have to identify how many forces are acting on that and in which direction acceleration is there, which direction acceleration is not there. Accordingly I'll apply Newton's law. Yes or no? So first I took mass. Now you know as this mass is present on this floor, so here one normal reaction will act upward direction N. Yes or no? Now another force which is gravitational force, that will act downward direction, that is basically weight of this object, original weight mg. Yes or no? Weight always downward direction, vertically downward. Listen, next what we'll do, this object is moving which direction? Upward direction. Upward direction with what? Acceleration, a acceleration. Now you say me, this object is moving with acceleration a upward direction. That means what? On this object two forces are acting. One force is N, another force is mg. This object is moving upward direction. That means this N is greater. N is taking that mass m towards upward direction. Yes or no? So now what I'll do here, I'll apply Newton's. Here itself I'll apply. Here applying Newton's second law. We will apply Newton's second law. What is Newton's second law? Net force acting on the object, basically mass times acceleration when mass is constant. Now next listen, F net is nothing but total net force acting how much? Now see, this force is able to take this object upward direction means this N value is greater. N value is what? Greater. See, suppose on me two forces are acting. One is upward, one is downward. But I am moving upward direction. So which force greater? This N force greater, upward force greater. So I'll write F net is what? N is greater force minus smaller force, which is mg. So N minus mg equal to mass of this object into acceleration, upward acceleration, so ma. Now if I want to write here N, how much I'll get? Tell how much I'll get? Ma plus mg. Now can I take m common? So what I'll write here? Tell a plus g or g plus a. Yes or no? Anything you can write? So now listen what happened. Your normal weight is how much? Mg. But here normal reaction when I am finding now, that is actually coming what? With mg another term is added. What is that? Ma. So that means what happened? Your normal reaction is little greater than what? Mg. Yes or no? So this weight machine, whatever reading will take weight machine. If reading I'll ask you, what is the reading of weight machine? Reading of weight machine, that will be nothing but this is your n value, and this n value already what you got? You got mg plus ma. That means this weight machine will measure the weight how much? More than your original weight. That's why in a lift, when you are moving upward direction, when we are going to shopping mall and your lift is moving upward, you are going to the 5th floor from the ground floor because you want to buy your dress, nice dress, right? Yes or no? So that time when you are going upward direction, what is happening? Now you feel inside, you will feel some pressure. Okay, you can observe that. But when you fall downward direction, when lift is coming downward direction, that time some different feeling. I'll tell that one also. Okay, but first you understand when going upward. So mg plus m, you feel like your weight increased or some pressure like when you're going. You feel once. Okay, go to Pachapa or go to Chennai shopping mall, whatever. Okay. Now, when you go next time, you observe. When you are going upward direction, you will feel something. When coming downward direction, you will feel something. Yes or no? So what you feel basically, now here your weight is increasing like mg plus ma happening. Okay, because of Newton's second law, whatever you applied here, you got n value. So now in this question, if you want to find a normal reaction, or you want to find reading of weight machine, or you want to find apparent weight of this person who is standing here, okay, or object who is there, that normal reaction nothing but what? M into G plus A. M into G plus A. Okay, or A plus G, whatever you can write, no reach. Clear idea? Now if A value given in question, G value given in question, mass value given in question, then easily you can find a normal reaction. Yes or no? Clear idea? No doubt here? Okay. Now we already went up, then definitely you have to come down. So next case is what? If lift is moving downward with acceleration A. With acceleration A. We'll see that one. So complete everyone. Complete this. Need to complete. So this formula, remember, what is your normal reaction is coming. And if weight of or reading of weight machine they ask, then also that is nothing but N. That is nothing but N. Case 2. Case 2. What is case 2? Lift is moving downward with acceleration how much? A. Acceleration A. Now listen here. I consider here one object inside a lift. Now this lift is moving downward with acceleration A. Yes or no? So already I told you, if you want to analyze this motion or you want to find the normal reaction here, you want to find the normal reaction between what and what? Now M and normal reaction between M and the floor or reading of weight machine. Then what you have to do? Now you have to do the free body diagram. So do everyone free body diagram. Let me write here FBD of M. Free body diagram of M. Definitely upward direction who will act? Normal reaction. Downward direction what will act? mg. Boys. Now tell acceleration downward or upward? Downward. So acceleration downward A. Yes or no? Now I want to apply Newton's second law here. Tell me. Now I want to applying Newton's second law. You will apply that. What I'll write? You say what I'll write? Net force equal to net force in vertical direction equal to mass times acceleration. Now net force is what you say? N is mg. N and mg. Very good. So your two forces are there, N and mg. And you see here this object is moving downward direction. That means this mg will be greater. That one is making it to move downward. You understand like that? So now this mg minus n equal to what? ma. Now if you want to find n here, how to find? Now mg minus ma equal to n. Now if n I want to write, it is mg minus ma, or m take common, g minus a. That means mg is your original weight. But now normal reaction is coming. less than your original weight. Yes or no? So when you fall in a lift or a lift is moving downward, you will feel weightlessness. What will feel? Weightless. You feel when coming from 5th floor to 1st floor, okay, after buying dress, what will feel? You are when lift is moving downward, you will feel weightless. Okay, yourself you will feel light, weightless. Okay, so that is what is coming here. So if you want to write here, this is the weight machine suppose, and if you want to write also what is the reading of weight machine, that is nothing but N, which is mg minus ma, mg minus ma. Okay, or if you want to find normal reaction also here. So this is a normal reaction. This is normal reaction between what and what? Normal reaction between M and floor, M and lift floor, M and lift floor. So this is the normal reaction between M and lift floor. Yes or no? Floor of the lift and M, between that normal reaction. A reading of weight machine also find now, you can find that. Okay. So all the together I am giving idea. If any question comes, you can do it. Okay. Ma, getting the point? Normal reaction, case 1, case 2. Now, in this particular case, if you are coming with acceleration g, that means suppose free fall. If you are freely falling, yes or no? That time what will happen? That time what will happen? If A is G, tell me, if A is G, what will happen? A is G. M into G minus G. G minus G what? 0. That means what will happen? Normal reaction 0. Yes or no? Reading of weight machine also 0. So you remember when lift na, in lift some cable will be there here, right? Yes or no? Cable will be there. If that cable will detach from that attachment, then what will happen, you say? What will happen? You will fall freely. You will feel weightless. N equal to 0, no normal reaction acting. Okay? No normal reaction acting on you. So you will be floating inside that lift. Okay? So note it down. For A equal to G case, A equal to G case will take free fall. We'll see what is happening. Or in this case you write also, in this case itself you write. Write star mark point for A equal to G, that is a free fall case, freely falling object, free fall. You write normal reaction equal to mg minus G, which is 0. So normal reaction is 0, no normal reaction. So star mark point give and write for free fall, your normal reaction is 0. Okay. And sometimes these questions also they can ask inside lift, one portion is there, mass is m. If it is moving vertically downward or downward direction with acceleration a, what is its normal reaction? Now this is the normal reaction, mg minus ma, mg minus ma. So a person is inside lift, it is coming downward direction with acceleration a, then what is its normal reaction? mg minus ma. Clear? No doubt? Okay. Now suppose you are moving constant velocity, either upward or downward. You are moving with constant velocity. What will happen? Acceleration 0. So in the both the cases you put acceleration 0. So no, normal reaction what will come? mg. Normal reaction equal to mg. In both case 1 and case 2, if you are moving with constant velocity, the normal reaction will be your weight. That means when you are moving with uniform velocity, okay, your normal reaction is equal to your actual weight. So weight machine will read your actual weight. Yes or no? Clear? Okay. And lift at rest means lift at rest, no acceleration, acceleration 0. So n equal to what? Mg. N equal to mg. So when lift is at rest or lift is moving with constant velocity, that time normal reaction equal to actual weight. So now come to next case. Did you complete everyone? Next write case 3. Case 3. What is case 3? If your lift is moving with constant velocity, moving with constant velocity, constant velocity. So either you go upward direction or this mass m, it is moving with constant velocity, velocity constant, or you are moving with downward direction, whatever it is. Mass m moving with constant velocity. So when you move with constant velocity, your normal reaction how much tell? Mg, only Mg. Why? Because velocity constant. Velocity constant implies acceleration 0. Velocity constant implies acceleration 0. So when you are moving with constant velocity, your normal reaction equal to mg. Case 4, suppose lift is at rest. Lift is at rest. Lift is at rest. What is the normal reaction tell? Lift is not moving. Not moving. At rest. Acceleration 0. Velocity also 0. Both the cases for lift 0. So now normal reaction how much? Normal reaction will be also mg, as before previous case. Normal reaction equal to mg. So when lift is at rest, normal reaction mg. When lift is moving with constant velocity, this one. Here what is happening? When object is not moving, if I do the free body diagram, this is your m, this is your n, this is your mg. So there is no motion, no movement, acceleration 0. So n equal to mg, upward force equal to downward force, n equal to mg. There is no motion now, then upward force equal to downward force. Clear? No acceleration is there, upward force equal to downward force. Clear or not? Am I getting? So when lift is at rest, normal reaction equal to mg. When lift is moving with constant velocity or basically called uniform velocity. Okay, or basically called what? Uniform velocity. Uniform velocity. Okay, constant velocity. Boys, clear? No doubt? Getting the points? Right man, nothing is there here. Just one mass you do, you just do that. Lift is at rest, lift moving. That box basically lift, okay? Don't get confused, this box were taken as a lift. You write yourself, you check and write yourself. No risk. Let me go for a next case. After that I will give time to write, okay? Next case, let me go. Case 5. Case 5, listen. Two bodies in contact. Listen. Two bodies in contact. If two bodies are in contact, then you find normal reaction. If two bodies are in contact, then find what is normal reaction. All of you listen. You take a floor here. Now this is one mass m. This is another mass m2. m1, m2. Now here one force applied F. Now what we need to find? Now we have to find the normal reaction. Normal reaction between m1 and m2. Normal reaction between m1 and m2. Let's consider m. So this one we have to find here. Okay. All of you listen carefully. This is your floor. This is your floor. And I told to solve this question or to find the normal reaction, what to do? Free body diagram. Now first to do free body diagram of M1. If M1 free body diagram will do, you'll see M1 is like this. From left side one force applied, and downward will be basically mg, upward will basically one normal reaction. Let's take N1, and see, if you are giving force in this direction, this object will move which direction? You are giving force in this direction, so definitely object will move in this direction. So right side, let's take one acceleration A. Let's take acceleration what? A. Now all of you listen. In vertical direction, no motion. In vertical direction, no motion. So what we'll do here? Now you can write N1 equal to M1G. N1 equal to M1G. This one you can write. Vertical direction, no motion. But in horizontal direction, one motion is there. See, you have given a force like this. Now on this side, one force will be acting. Can you say what is that force? Here, this is a contact surface, right? This is basically contact surface. On this contact surface, one force will be acting. Can you tell what is that force? Normal reaction. How it will be act? Now it will be acting perpendicular to the contact surface. So for this one, it will be acting like this. M2 will give one normal reaction M1. That is nothing but N. That That N you have to find here. Okay. Now see. Now if I will do here, in vertical direction I got this equation. Now if I want to find in horizontal direction, what is your equation? Now see here, object is moving right side. So force direction, F direction right side. So we will apply F net equal to MA. I'll get F minus N equal to M1A. I'm getting one equation like this. Yes or no? Clear idea? Now can you tell what is acceleration of the system? Can you say what is acceleration of the system? See, acceleration of system. If acceleration of system I want to find, acceleration of system, listen, that A should be total force acting F divided by total mass. How much it is? M1 plus M. So acceleration equal to force by mass. Now if this acceleration value I will substitute here, I will get what value? N value. Yes or no? I will get N value. You substitute. But I want to do little free body diagram of M2. So if M2 free body diagram I'll draw here. See what I am getting. Here this is your M2. On M2 a normal reaction N2. Downward is basically M2G. And in this from left side one force will act, that is normal reaction N. See here, M1 will push this M2 as N force, with N force. Yes or no? So one normal reaction acting N in this direction. Now what to do? Now here acceleration is vertical direction here. Vertical direction. Listen, here free body diagram of M2. If M2 I'll do, see here, acceleration is towards right. Now next listen here, N2 and M2G, they both will balance because vertical direction no motion. So now listen here, in vertical direction there is no motion. Vertical direction no motion. So what I can write? I can write N2 equal to M2G. N2 equal to M2G directly I can write. Now next listen. In a horizontal direction, if I'll check, in a horizontal direction, what I'll get? Now see, for this M2, there is only force responsible for the motion. What is that force? N. So that means I can write N equal to what? M2 into A. M2 into A. Already A value you got or not? Now substitute there. What it is? M2 into F divided by M1 plus M2. Now see, this is your normal reaction. So that means if you will consider the second body free body diagram, easily you are getting normal reaction. But if you will consider free body diagram of M1, little time it will take to calculate. If the same expression will get, same answer will come. N value, same answer will come. If A will substitute here and you will calculate. Okay, you calculate and check. And here one tricks I will tell you to remember this normal reaction. See, this force is connected to M1. Force is connected to what? M1 object. Not connected to what? M2. Now if I want to find normal reaction here, what is the normal reaction value? Now it is not connected. Which object it is not connected? M2. That one you take first. M2. Multiply with the applied force. Divided by addition of the masses. Okay. Now suppose in the next case I will tell this F is in contact with M2. Then what will be normal reaction? M1 into F by M1 plus M2. Yes or no? Like that you can calculate. But this is the perfect method. According to Newton's second law, applying Newton's second law and free body diagram, we are calculating this normal reaction. Yes or no? I hope you understood. Clear idea? Okay. So acceleration of system, you remember, as F is this direction, and here I considered it is a smooth surface. There is not rough surface, no friction is there. So object will move in this direction with acceleration this much. So this is the acceleration of the system. Acceleration system also remember. You consider this total mass. You considered M1 plus M2. You consider like this and you took. It is moving with A and force applied F. You consider this one and you wrote acceleration equal to total force by total mass. Okay. Did you understand everyone? Normal reaction, can you remember? Yes or no? So this is what we want to calculate. And your homework is you calculate, substitute this A here and you check this normal reaction you are getting or not, this value you are getting or not. M2F by M1 plus M2. Okay. I hope you understood, right? Okay. And according to shortcut trick, if another case I will give you, suppose I am giving here case 6. Okay, what is that case? Now one mass is there M1, here one mass is there M2, here one force acting F. Yes or no? Then what is the normal reaction between M1 and M2? Now M1 F. M1 is not a direct contact with F. So first you take M1. M1 F by M1 plus M. And what is the acceleration of the system? Total force is F. Total mass is M1 plus M2. So this is the total acceleration. Yes or no? So this is your acceleration of system. And this is your what? Normal reaction between what and what? Tell? M1 and M. Okay. And object will accelerate in this direction. Left side it will accelerate. Yes or no? You can verify this sixth case. You can verify with that whatever derivation we did. I hope you understand, right? Yes or no? Okay. Like, subscribe Vidya Lakshmi NEET Academy YouTube channel. All the very best.